the data which has output. So for example, if we have 10 million emails and we have these emails and it's labeled by spam and non-spam, for example, this is a label data. But if we have a huge amount of reviews or a huge amount of literature or news or whatever, and we don't have discrimination or we don't have labeling for each one to know what type of it, this is unlabeled data. The main difference between text classification and text clustering, which is whether it's working at label or unlabeled data. So text classification, it's applied to label data. So label data, we have each review or each sentiment or each phrase or each sentence, and we have its type right now. But unlabeled data, we have it without knowing what type of it. So overview, the role of text classification and clustering in medical field. So text classification, creating categories of or to text document. While text clustering, it's a grouping similar text document together without predefined labels. And we have a lot of application at medical field like diagnosis, research, and patient management fields, exactly as we see in a minute. If we go more steps or deeper at text classification, what is text classification? Generally, text classification is to create a machine learning algorithm to define exactly what is type of each sentence or each review or each sentence and so on. And it has a huge importance at medical field. For example, in enhancing clinical decision support, a lot of doctors, they are just need assistant to just help them to take the right decision for each patient. Sometimes this assistant, it can help them to tell them whether this patient is like, yeah, I'm sorry, there is a voice here. So this assistant, it can help them to just tell them what is the right diagnosis for them, whether they need a treatment or not, whether they need a surgery or not. This is a depth of medical field, right? This is enhanced clinical decision support. Also efficient information retrieval, because right now any hospital, any surgery, any clinic, they have access to a huge amount of text. How can we retrieve enough information from this a huge amount of data in the right time without spending a lot of time in searching for what we need? Text classification help in this field. Also, automated coding and billing. Right now, each patient, they have specific code which helps the clinic or surgery or the hospital to define them. Also the surgery, also the process for them, also the medicine, everything it's coded right now. So to help taking the right decision and to connect between each patient and their processing and their decision and their medicine, this is very, very important thing which can be used using AI. We have a huge examples of medical fields of using text classification and medical fields. For example, clinical documentation and coding, disease and symptoms diagnosis. Just let's imagine something. If we have a poor city at some country and they has only few number of doctors. Let's imagine the suffer of those patients to have a time or like a queue on the waiting list until they see the doctor. And then how much money they need to pay for him to take the right decision. How about if we created a machine learning or an AI algorithm to just help the patient to give them the right diagnosis using this as symptoms? This can be developed using text classification. Also sentiment analysis, patient feedback, which we'll talk in a minute. Also medication and treatment recommendation, which is very, very vital and important step in this field. If we move to text clustering, and again, let's remind ourselves, the main difference between text classification and text clustering, that text classification, we are working and we are using a label data, which is indeed has a code or a label for each phrase, while text clustering, we are just talking about a huge amount of undiscriminated data. So text clustering, what's text clustering? It is digging and diving within this huge amount of text and get the right information from it. Also, to group all these data into specific categories. Let's just have like a few examples. If we have here a huge amount of data here, text clustering is to ask the model to read all these data and to group them into a different types of groups where each group contain a similar amount of sentences together. For example, if we have here a diagnosis from doctors, for example, 100,000 diagnoses. If we make a text clustering right now and we ask the model to make it for 4 groups A, B, C, and D, for example. So if we checked all diagnoses which exist here at this group, we might find that all diagnoses here has a specific common factor among them, which is, for example, it's for children who are under 12 years and who are suffer from cough and so on. And we can find that all this it's for women who are suffering a blah blah blah. And if we are checked here, we can find it's related to like car injury or something. What this means? It means that text clustering, it make groups of unlabeled data and it combine and selecting and picking each sentences and grouping them depend on their similarity between them, which is something very, very important and very, very useful at either all machine learning algorithms or especially medical fields. It depends on several techniques like hierarchical clustering or k-means or db-scan. This is like a mathematical equation using it, and it doesn't matter so much what is the mathematical equation right now, but we need to know more about their application and how can we use it at our applications. There is a huge amount of examples of text clustering at medical fields. For example, grouping patient records. For example, we are a hospital and we have tens of thousands of records of patients. Maybe we need to group them to make like 5 or 6 groups. So here, group A, for example, which is mainly the patients who came to the hospital and take like medication for 1 or 2 days, and they are dismissed quickly and their processing or their processes went well. And this is group B, who are just keep complaining about something, while doctors, when they check them, they found nothing wrong with them. And this is group C, with features A, B, C, D, and so on. So making a discriminated groups A, B, C, D, it helps the hospital management itself. It helps them to treat each group with the suitable treatment way. It helps even checking whether if there's like a next customer or patient to know how they think and what group they should belong to them and so on. How about medical literature review? How about symptoms analysis? How about healthcare service feedback? There is a lot to talk about this, but of course we don't have time for all this. So that's understanding text processing. Let's move to my work. And of course my work, again, it's mainly depend on telecom data. But let's say something that mainly the tools which is used for AI and machine learning and text processing, it's very common and it's very easy to move from field to a field. So what I did indeed at the past 3 years at my PhD at telecom data, it can easily be applied to any other field like medical fields and so on. So first, I digged about what's called GSDMM clustering analysis. And GSDMM, which is Gibbs Sampling Dirichlet Multinomial Mixture. It's one of the like a complicated clustering tools, which is mainly make a clustering depend on the similar feature at each sentence and so on. So I apply this to telecom data, and my main point is to how to fine-tuning the hyperparameters for it, because there is what's called alpha and beta, which is the parameters of the model, and how to optimize them and find the suitable and optimized values for alpha and beta which should be suitable for applying this. I applied it indeed, I got a great results, and I published a paper for it. Then, and here is the steps of applying it. First, I get the data. I make data cleansing to remove all unwanted letters, to remove all non-English letters, to remove all words which is not suitable to our data. Then I apply GSDMM clustering until I get the number of clusters I need. And they are applied word embedding. And generally word embedding, it's one of the most important expressions at text processing and natural language processing field. Generally word embedding means the under meaning of each word. It means the numerical value of this word. For example, we as human, if I told you a word apple, once I told you apple, you have a specific image or specific illustration at your mind, right? Either the fruit or the phone, right? If I told you sky, if I told you star, if I told you ocean, if I told you even some things which is like untouchable, like envy, like freedom. So each word, it has a specific impression to your mind, right? Because you are human. How about machine? How about computer? 20 years ago, if I type the word apple to computer, it just treated it as letters, right? It treated it as decimals, numbers. It's just letters for it. So it didn't know what this word mean. So the word apple and the word envy, the word freedom, the word ocean, for the computer, it doesn't mean anything. But for human, it means a lot. The word embedding is trying to let the computer know more about word once it hear or it listen or it read this word. This is very simply the word embedding. And we have this famous example, which is the three words: house, horse, apartment. The two words house and horse, those two words, they are very similar with letters, but they are very far in meaning. House and apartment, they are very far in spelling and words, but they are very similar in meaning, right? So the computer or the machine algorithm, if it worked well or if it passed the test of word embedding, when it knew that the correlation or the gap between house and apartment, it's less than the house and horse. This is very general, the word embedding. The word embedding, it depends on make a numerical vector for each word. They started it by making for English. Why English? Because it's a very common language. Because maybe it's the most spoken language all over the world. But after that, when they developed it, they expanded it to every other language in the world. And it's very easy to apply to any language at the world, as much as we have enough data for it. Because if we have like a rare language which don't have enough data, it would be very difficult to apply any word embedding algorithm to it, because it's exactly as a child. For example, at my own language, which is Arabic, if I told you word tufaha, it means apple, right? The Arabic child, if a child born at any Arabic country, when he was like 1 or 2 years, when he start to hear the word tufaha, so he don't know what about it, right? But year by year, when he start to listen why and when and where it used, he or he can start to build a numerical vector of meaning of it. It's inside his mind. So without telling this child what tufaha means, he mean about it. This is exactly how word embedding algorithms know, or how it learn. How? By knowing each word, where and how it used and so on. Of course, this is a big topic which cannot be discussed here, but this is quickly what and how word embedding works. So I use word embedding, and generally it's just to convert each word into numerical vectors to let the computer know about it. And then measuring distances. And here, because when I make the separate clusters, I need to know cluster A and cluster B, whether they are close to each other or far from each other. How? Using numerical vectors. Because computers cannot use anything except mathematics. So I need to use word embedding to convert all words to numerical vectors, and then using Euclidean equation to measure the distance between each group and each other group, to make sure that all groups are far from each other. Why far? Because the perfect clustering work when each clusters are far from each other, because we don't need a groups which is near to each other. We need a very discriminated groups far from each other, not two topics which they are close to each other. And then to use evaluation metrics to just make sure that all clustering are work. Again, this is a very complicated work which cannot be discussed in few minutes. And here is the link of my paper which is published me with Malgorzata and Craig. You can return to it to know more about it. And here's a results from my work at GSDMM clustering. Quickly, here is like topic 1, topic 2, topic 3. For example, here the top repeated words. For example, at topic 1, it's the most repeated word, which is like service, customer, phone, year, problem, and so on. And we name it as a service, and it was like 84% of the data, because we have, I think, like 100,000 review, so it was like 48% related to topic 1. Topic 2 has two words, phone, tell, customers, and so, and here is the topic name, and here is the percentage, and so on. And all this related to Orange. What is Orange? It's just related to the company, which is Orange Telecom. And here for Vodafone, here is for Virgin Media, and so on. Of course, this is like one table of many tables we have, because we have a lot of works here. I need to quickly go because we have only 9 minutes. Here is another things of my work, which is again using word embedding at text classification. And the steps were like that: make data scraping, download a huge amount of data from Trustpilot, apply data cleansing, make data slicing to just make like several files, which is either contain 1,000 or 5,000 or 10,000 reviews, applying word embedding tools, again to apply this tool to convert text into numerical vectors. And I applied several word embedding tools like what's called Word2Vec PCA, fast text average, fast text PCA, paired, TF-IDF, Doc2Vec, and so on. And then applying classifiers and then get results. Again, more details, it's published at this paper, which is appeared here. And here's like a result or one of my charts, which is here the 13 word embedding tools at horizontal axis. At vertical axis, I have evaluation metrics, which is either precision, recall, and inference score. And here we can compare between precision, recall, and inference score for each word embedding to know which one is working well and which word embedding tool is able to exactly extract the exact meaning of each word, and so on. So let's move to medical field. Okay, we need to apply text processing, natural language processing to medical field. How it work? First, natural language processing in medical field, it's very viral and it's very important, and it's developing day by day. And right now, we can say that the doctor who is not knowing enough about natural language processing and AI, he will suffer that he will not be able to use tools, modern tools at his field. It's very important for anybody who is studying or working at medical field to know basics of AI and NLP, which is natural language processing. Because generally natural language processing, its importance, which is accuracy, time, and cost. You cannot just imagine how accurate is natural language processing tools. Yes, we can say that it's right now better than human at a lot of fields. At many fields, its accuracy, it's very, very more precise than people. And time, of course, there is no comparison. You can just imagine a doctor who is suffering, reading or analyzing tens of thousands of receipts or something, while computer can make it in a part of second. And cost, again, we cannot compare between costs. Computer can make millions and millions of tasks without any mention or without any noticeable cost, while salaries and fees for any human doing it will be tens of thousands of times of this. And of course, it can be applied for like clinical text mining, EHR analysis, disease surveillance and outbreaking detection, medical literature review and information extraction. The fields, it's uncountable, and it's expanding day by day, depending on how accurate and how famous and how like successful of tools using at this here. And again, using medical fields at feature engineering. The feature engineering, it's a very huge and wide field at AI. Again, we cannot talk about it here in these few minutes. It needs sessions and sessions to talk about it. But we can make a very quick like summarization about feature engineering, that how and why we can extract more data from this data. Again, how and why we can extract more information from this data. So, for example, maybe a hospital has several gigabytes of data. Maybe records from the patients, maybe reviews, maybe bills. There's several gigabytes of data. The feature engineering and feature extraction, it's how we can get a useful information from this. How can we get benefits from this? And this is like a field where more smart tools in this field, it equals a lot of benefits using it. Because maybe a hospital, they are able to extract more information, things from there. For example, they can get a pattern of behavior of patients when they come and how and what they do here, how much they pay, and then they return. So they can make algorithms to predict how much they can pay for this service, so they can make a precise pricing for each service here. This is a very example field, or this is very simple example of how to make feature extraction. The feature extraction field, it's a very important field, which only smart people can gain more details in this field. So feature engineering, it depends on data collection, and precising or scribing the precise and the clean data which will be useful for our field, data cleansing, then feature engineering, then apply the proper models. LLMs and medical fields. LLMs, it's something kinda new. Just a few years ago when they start to talk about LLM, which is large language model. And large language model, it's mainly used when we found that right now at 2020, starting 2020 until now, we have a huge amount of data, which is it's uncountable amount of data which is text. And thanks for social media platforms, for the websites, for the expansion of using mobile phone, which make everybody right now texting, send the messages, send the emails, make reviews everywhere. All this amount of data, machine learning engineers and data scientists, they were able to build the algorithms to learn from it, to know the pattern, to know more how people think, how people talk. And you know what? LLMs, if you need to ask what is the direct results of LLMs, I can tell you Chatbot GPT. Chatbot GPT and other GPT alternatives, it depend on LLMs. Because how much fluent is GPT to you, it depends on how much data it learned and how much data he faced and he know from it, which tell them, which is GPT and any other chatbots, how to give you a precise examples and so on. So LLM is very useful at medical fields, and the more data we have, the more precise decision we will have here. How about challenges? We have a quick challenges at medical field. For example, first, data privacy and security. And we can see that it's the main obstacle at using data science and machine learning at medical field. Because of course, we are not talking about like a social media platforms or a reviews or a comments, which is at like Facebook or Twitter, which is very public and we can easily use it anonymously. No, we are talking about a very confidential data from patients where many patients and of course firms and hospitals, they are completely refused to use it even if it was anonymously. So building your algorithm and letting them learn from this data while keeping the privacy and confidentiality of this data, it's a very big challenge which we face while we're working. Also, data heterogeneity. Whether your data is it heterogeneous or not, whether they are homogeneous or very heterogeneous or not, whether it's just like resembling or just making a good sample from all the data which you need. Because if your data was not exactly resemble or they are not reflecting the good ratios of all communities of the data you are working, your result will be biased completely. Also, difference in language and terminology, variations here, because maybe some doctors use some words here which isn't used by other doctors, and also bias and fairness. The last thing, we can quickly go to insights and graphs. Here example of applying text classification for NHS feedbacks. And this is used by my colleague Heinz C using Palomino Marco or under supervision of Professor Palomino Marco. And here is quickly the steps how they use it here, like using raw input text and removing all names, making deconization, making lemmatization, and removing all numeric, then using data cleansing, TF-IDF, generating bag of words, text features, and lastly training classifiers. Also, my colleague Malurachi, with the supervision of Dr. Malgorzata, she applied what's called analyzing NHS survey result using natural language processing and sentence analysis. And generally, sentence analysis, it depends on the understanding the review, whether it was good, bad, neutral, supportive, disappointed, and so on, to get exact emotions under the word of this or these words. And applying graphs and text classification. Here example, here is applying text classification, and here is a link of it's a source. Here is apply text clustering, for example, at medical field, like here, like details of maybe symptoms or something, and make a clustering to just group each amount of sentence into a specific group. And here applies text segmentation. For example, here is a point for cardiology, here for dermatology, here is for endocrinology, and so to just again to group each amount of sentences into the similar group here and so on. And last thing, which is word cloud, which just know and get most repeated words in a suitable graph, so people can know what is the most repeated words at each reviews here and so on. And here word embedding, as we talk about, if we see these colors, for example, all words with green color, which is like heart, brain, lung, liver, kidney, while all words with the red color, which is RIHD, CHF, CKD, while all words with the blue colors, you can see that all words with the same color, they have something in common. And this is mainly the idea of word embedding. And here, the data mining to extract more data about it as we talk. And here's the reference, my paper and other papers of my colleagues. Thank you so much for your time, and any question I will be happy to answer it.